In this video we're going to look at the antiderivative of ax plus b all raised to the power of n. Now the Essentials textbook uses the letter R, but the VCAR formula sheet that you get in the exams and in the study design, it actually uses the letter N. So that's the letter that I'm going to work with, and it sits comfortably with all of the work that we've done with differentiation using N as our power up here as well. So there's two parts to the video. The first part, we're going to look at this first formula, which is the one that appears on the VCAR formula sheet. We're going to look at this in particular, and it's a pattern that we're going to follow. So when it looks like this, this is the antiderivative, this is the integral, we have plus c on the end as our integration constant, but this formula only works when our power is not equal to -1. So in the second part of this chapter, in the video on the second part, we're going to look at this second formula that is also on the VCAR formula sheet. So this is a special case of this, where you can see the power is -1 here. And also one that a formula that's not on the formula sheet, but it's regularly used in the exams, which is this one here, and I'll explain all about this. These little purple lines here, they're the absolute value or the magnitude of ax plus b, so that's whatever its value is, it's the positive version of the value. So if the value is -3, the actual value that you put in there is 3. So my tip for you for the exams, put this formula into your memory and put it into your bound book as well. Like I said, it's regularly used on the exam, but it does not appear on the formula sheet. So I'm going to go through where the actual formula comes from. If you're not interested in this, by all means fast forward across, but I'll show you where the actual formula for the integral comes from. So if we start with differentiating this particular function here, this is a composite function, so we've got an inner function and an outer function. So the inner function is in green, the outer function is in yellow. So when we differentiate that, we use the chain rule. So the chain rule says the answer is the derivative of the inner with respect to x times by the derivative of the outer function. So the power of n plus 1 comes out the front and the power drops by 1 with the inner function fully shown inside. So this is the derivative of that. So if we go in reverse, so we've differentiated to get this. So if we integrate both sides, what we should get back to is the original function. Let me say that again. If we integrate both sides, if we integrate here and we integrate here, what we'll get is back to the original function. So in reverse, if we integrate this side, which is what I've shown here, that gives you the original function plus your integration constant. All right. So the letter a is a constant because that's a coefficient of x. The power n plus 1 is a constant as well because that's a power, and so we know that those two are constants, so we can bring them out the front of the integral. And so now our integral looks like this, and you can see it's starting to look like the formula on the formula sheet. Now because these are just numbers and these are multiplying that integral, I'm going to divide both sides by these numbers, or another way to think about it is I'm going to multiply both sides by 1 on a times n plus 1. If I do that on this side, that will disappear and then it appears here, and then that is what we've got on our formula sheet. So let's look at using the formula. So the formula uses the coefficient of x and the power that the linear function is raised to in the derivative formula, and we have to remember to put plus c on it. Okay, so as we go through these examples, the first thing you want to note, let's look at example 1 here, is we need to know the coefficient of x, which is 2, and we need to know the power, which is 3, and then we just follow the pattern. So our a is 2 and our n is 3, so the formula says that we do 1 over a times n plus 1 write the formula, increase by 1 and put plus c. So now we're just going to tidy this up here. Oops, didn't mean to do that. Tidy this up here by multiplying this all together. So 2 times 4 is 8. So we just write it as 8. And of course our power comes together to be 4 plus c. Now, if you do this on your CAS calculator, if you integrate this on your CAS calculator does not give you the plus c. You need to remember to write that. So let's look at number 2. It kind of looks like there's a linear function, but it doesn't have a power. But what you need to remember is that square root is in fact actually to the power of a half. And the a value that we use in our formula is not the first number that appears in the brackets, it's actually the coefficient of x. So in this case, our coefficient of x is minus 3. So now we've identified our a, we've identified our n value, and so we follow the pattern in the formula, remembering that we need to put plus c on the end. Now you can see that we're going to, you can see here that we're going to have to do some fraction work to tidy this up a little bit. And this is where most people would make a mistake doing this. So I'll just move this up. Come on, move up. And let's have a look at how we work this out. So, oh, I just left it. I didn't work it out. All right, so let me work it out for you now. Okay, so this bit here I've got over here, so I've got 1 over minus 3 times a half plus 1 is 3 over 2. So that's 1 divided by, multiply this together, so that gives you minus 9 on 2. So you're dividing by a fraction, so you multiply and flip the fraction, and that ends up with your minus 2 over 9, and that's your final answer there. So let's have a look at another question. Let's just move over this way. Okay, so let's look at this one. Again, it doesn't look exactly like it appears on the formula sheet, but we can write this 1 over to the power of 3 as minus 3, and then we have exactly what we had on the formula sheet before. We follow the pattern. Follow the pattern and simplify out to get our answer. So here, minus 3 plus 1 is minus 2, 4 times minus 2 is minus 8, and our minus 3 plus 1 is minus 2. And then finally, let's look at this one. Let's just go here. Sorry, I've got boxes flying all over the place here. All right, so this is the integral of 24 over the square root of 9 plus 6t dt. So the 24 is a constant multiple. So we can bring the 24 out the front, and that leaves us with 1 over. And this square root here is to the power of a half. So this is why I've got 1 over gives you minus the power of a half. So now I've got everything that I need to use my formula with this 24 out the front. So the 24 is multiplying the whole of this integral. And so when I'm doing my working out, the 24 is multiplying the whole of my integral. Goodness gracious me, what's going on there? So you can see I've got 24 and then square brackets around the whole thing. So I use the formula pattern on this with my a as a 16. So 16, my power is minus a half, so minus a half plus 1. The power becomes minus a half plus 1. I'll tidy those up algebraically. Let's move all this out the way. So we've got 24 times 16 minus a half plus 1 is a half. That becomes a half. This will simplify to 8. And we're left with this. Now I'm going to multiply through by 24, and I know that you're going to want to do 24 times the first thing and then 24 times the c. But let's just talk about the 24 times by the c, because if we do the 24 times by the c, what we need to remember, whoops, come back here, is that our c value is a constant. And we've got 24 times by a constant, and 24 times by a constant gives you another constant. So you can actually just write it as plus c. So 24 times a constant, just plus c. I know this is going to mess with your heads a little bit, but this is generally how we do it. So we just leave it as a single plus c rather than the 24c.